So, I am a complete beginner. I have no idea how to build anything in Web3. So, if you're here for good or solid knowledge, this is the wrong place. This is not the place it should be. Here will be no solid knowledge. My background is more in building web apps and like connecting APIs, backends, and designing some small algorithms just to do the job instead of making crazy stuff that is like very hyped up and everything. Like, I'm not into the hyped up stuff, so I am going to try and explore what is not hyped, what is hyped, what is what and everything, and we'll see. Okay, let's jump into it. So, first and for all, I am going to see what is Web3. Let's do Web3.js first. Okay. Web3.js is a collection of TypeScript and JavaScript libraries that enables developers to interact with Ethereum and other EVM-compatible blocks. So how about why only Ethereum and EVM? Why not other Bitcoin? Okay, never mind. Using JavaScript to translate by communicating with the local or remote Ethereum node using connections. Let's see, introduction. So the second I open it up, it says that Web3 libraries are being sunset on March 4th, 2025 for migration guides. See the chain safe blog. Crazy. Like, the moment I'm trying to explore it's already gone. Web3.js to sunset. Sunsetting Web3.js. Libraries will be archived and everything for the past years. Developers will provide migration guides. Planned phases for sunset. We got Ether.js and VIEM. VM. Okay, cool. What's VM? VM. Build reliable apps and libraries with lightweight, composable, and type-safe modules that interface with Ethereum. Okay, so I see the idea is that you have a package and it helps you to interact with ETH. But we got interaction with ETH, but what does ETH provide us? That's the interesting question. Okay, composable modules, lightweight, performant, type safe. Fine. Import modules from Veeam. Import mainnet from chains. Okay, so we got different chains. Set up a client with desired chain and transport. Creating public client. Okay, consume in action. Block number, await client, get block number. Okay, first class API, interaction with smart. The browser stopped working. Cool. We cannot click now. I lost the clicking capabilities. Fine. So Web3 JS is down. It doesn't work. JS developer. Okay, so for JS developers, Ethereum is generally more accessible and versatile ecosystem for building applications than Bitcoin, primarily due to native support for smart contracts and developer toolkit that aligns with modern web development. Wow. Here is a detailed comparison from a JS developer's perspective: programming languages and smart contracts. Ethereum Solidity smart contracts are written to in Solidity, an object-oriented language heavily influenced by JS or C++. If you know JS, you will find Solidity syntax easy, turning complete but design security and gas efficient. Beat C. Script and DOCs. Okay, Bitcoin script is intentionally limited to prioritize security over complex programmability, while Lightning Network applications can use JS. Building complex dApps on Bitcoin requires specialized, less flexible languages on layer 2 solutions. Okay, cool. Okay, cool. 4 things listen to. Scaling and solutions shouldn't be afterthought. The scalability for your decentralized application depends on the scalability. Taking a selfie real quick. Applications depend on scalability and of the underlying blockchain on which it is built. ETH has high fees because the network isn't scalable. Wow. Similarly, Bitcoin has scalability challenges as its average block creation time and block size limit constrain its throughput. STX is taking the learnings from these two blockchains to tackle the scaling work before congestions becomes an issue. So what it says is Ethereum is just easier to get yourself hit in the head, to stab yourself in the foot or something like that. But Bitcoin makes it harder, but you still stab yourself when it comes to the time. Developer ecosystem and tooling. The JS advantage. Ethereum Web3 is built around this and that. Okay, you got React. Okay, that's really not good. Okay, development experience. Makes no sense. Solidity, similar to JS. Bitcoin or Ethereum? Let's see Ethereum versus Solana JS developers. Okay, we got this blog. Oh, somebody is watching us. Hey. I guess I can chat. Let me open up the chat real quick. Wait. Okay, I have the chat open. Let me send a quick emoji. Oh, we got 3 views. Okay, never mind. Let's continue. Since nobody is chatting. Solana and Ethereum. Comparative guide to performance and potential. So Ethereum employs a proof of stake POS algorithm, while Solana combines proof of history. That's interesting. That's interesting because and POS to create a hybrid that maximizes both speed and security. While Ethereum prioritizes decentralization and security, Solana emphasizes scalability, albeit with a concentrated validator set, which elicits concerns regarding centralization. It makes no sense, but let's continue. Ethereum boasts superior security due to its large validator set, unlike Solana, which limits participation with sophisticated hardware demands. The blockchain arena features 2 prominent platforms, Ethereum and Solana, each with distinct architecture philosophies. Solana boasts of a theoretical maximum of 65,000 transactions per second, while maintaining transaction costs under a penny. Wow, this is impressive. Yet Ethereum, a pioneer in smart contracts and dApps, commands the largest developer ecosystem and holds about 85 billion in DeFi protocols. Okay, so one makes a greater in volume while the other makes a greater in transaction costs. Okay. However, this isn't just a technical rivalry, it's a fundamental clash of philosophies with the potential to reshape how we interact with digital cash, art, apps. But which one is right for your DeFi project? Though both Ethereum and Solana blockchain aim to revolutionize finance, digital ownership, and gaming, they take radically different paths. Understanding their differences, similarities, and use cases allows developers to determine the optimal blockchain for the next dApp, and users to select the most appropriate chain for their intended use case. An overview of Ethereum and Solana blockchains. The fundamental challenge public blockchain aim to address is the blockchain trilemma. The belief that blockchain can only achieve 2 of the 3 critical aspects: decentralization, security, and scalability simultaneously. Most blockchains, including Bitcoin, prioritize security and decentralization but sacrifice speed. Ethereum and Solana represent different approaches to solving the persisting puzzle. But first, what are they? Originally launched in 2015, Ethereum stands the pioneer. Oh, I see. So, this decentralization, security, and scalability problem. Okay. However, Ethereum's popularity presents more challenges as the number of users on the network increased, the transaction speed declined, and the gas fees escalated. The Dancon and Pectra upgrades were recently implemented to lower transaction fees and improve throughput, addressing this issue. On the other hand, Solana presents itself as an alternative to Ethereum, aiming to address the growing need for scalability and adapt to the evolving demands of the industry. Proposed in 2017 and launched in 2020. Solana offers rapid transactions and low costs, positioning itself to support decentralized and scalable applications. Okay, modular versus monolithic. Ethereum modular approach. What do we have? ETH operates on a modular architecture that prioritizes security and decentralized over raw speed. Its base layer 1 is responsible for maintaining high security standards and processing transactions, while layer 2 solutions handle its base layer 1 is responsible for maintaining high security standards and processing transactions. Like, it gives no information whatsoever, while its layer 2 solutions handle the heavy lifting of speed and cost reduction. As such, the base layer validates the most critical operations, such as the scaling solutions such as rollups and sidechains. Okay. The scaling solutions such as rollups and sidechains process round routine transactions and settle the final results on the network. Rollups are layer 2 scaling solutions that perform transactions executions separately from the main network. They help increase network speed and lower transactions. Okay. ZK rollups. For every batch of transactions, ZK rollups broadcast a summary of required state changes along with the transaction data to the mainnet. They use cryptographic zero-knowledge proof ZKPs to submit validity proofs to confirm the correctness or accuracy of changes. This means the blockchain only stores those validity proofs instead of transaction data, which is comparably bulkier. However, most ZK rollups are designed to handle specific use cases of services such as token exchange between wallets or NFT swaps. So they are bulky. But why? And why are they made bulky? Data privacy growing. Okay, zero ZKPs are cryptography to help to access services while protecting your data. Okay. The thing with privacy is privacy issues are integrated in virtually every aspect of our lives. For example, you must supply the bank with your personal details, salary and credit score to get a loan. Similarly, the visa process asks you everything but your family tree, starting from your address proof to bank statements. Why should you need to reveal all your personal data in all its different dimensions to prove just one fact? It's not just the government or banking services that collect your data either, thanks to our reliance on digital services. Thanks to our reliance on digital services which can easily track what you're searching, clicking, and looking at, we live in an entirely data-driven society where every little is really private. Well, very little is private. For instance, if you are everything, what is zero knowledge proof? Put simply, zero knowledge proof, or ZKP, is a type of cryptography. It allows you to prove your identity or specific credentials to a third party without revealing any personal data. Okay, if you know, you know. Say your friend has told you, okay, I get it, I'll get it. Privacy and accuracy. Opposing forces of ZKP. It's important to understand that zero knowledge proof can never be 100% accurate. You reduce the probability of your statement being false each time you test it. You reduce the probability of your statement being false? Okay. There are two types of zero knowledge proofs, interactive and non-interactive. The examples used above are interactive in nature, meaning that proofer and verifier need to communicate with each other to prove their statements. As you can imagine, that's not scalable. That's why non-interactive ZKP is more popular. In non-interactive ZKP, the proofer and the verifier do not need to talk to each other to make the transactions. Instead, it's done through some pretty complex cryptography and hashing, which could make the article read like an academic paper if we start explaining. Where have ZKPs being used? Blockchain technologies and identity verification. I'm kind of interested in this. With zero knowledge proof, you can retain ownership of your identity instead of needing to ask you for your driver's license. Apps can verify you are you through zero knowledge proof techniques. We can supply just enough information to prove that we're eligible for certain services, adhere regulatory compliances, thus protecting sensitivity and identity. It would make processes like visa application, loans, and rent agreements, or even voting much simpler. This is very interesting. Wow, what blog is this? Ledger Academy. So I just clicked on a how should I say, on a academy, and then it just taught me most of the stuff. Okay, cool. Unlike ZK rollups, optimistic rollups assume the transaction data broadcasts to the main chain is accurate and valid. However, they are used to fraud-proving schema instead of invalid transaction and everything. Okay, let's continue with Ethereum versus Solana. Ethereum modular philosophy extend to ZK and optimistic rollup. It is this diversity that fosters a competitive ecosystem where varying scaling solutions can be specialized in specific use cases. Solana, monolithic design. Solana, known for its transaction speed and low costs, takes a monolithic approach in its attempts to solve scalability at the base layer itself, instead of relying on external scaling solutions like Counterpart. It integrates innovative technologies directly into its core protocol. To explain, Solana's monolithic single-layer design ensures all functions, executions, consensus, and data visibility are handled within a single blockchain. This design allows it to prioritize high speed, throughput, and low latency compared to Ethereum's modular approach. Solana's unified structure allows it to offer seamless user experience and enhanced performance for applications that require real-time responsiveness. However, this also limits its flexibility, such as when attempting to upgrade individual components without efficiently the entire chain. Consensus mechanism comparison. Ethereum's proof of stake post-merge. Okay, in September 2022, I know it's Solana's hybrid consensus model. Solana utilizes a unique blend of two consensus mechanisms, POS and proof of history, to create. Let's take a quick peek at POH. Oh. La la la. Boop, 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 boop. PH primarily focuses on this and that. Solana defines VDF, employs VDF, create timestamps. Okay, PNC of POH. POH, proof of history, consensus mechanism significantly increase network scalability as nodes know the specific time of previous transaction occurred. For example, Solana, which uses POH, can handle over 6,000 transactions per second. In addition, POH networks are also highly energy efficient, minimizing their global carbon footprint. On the flip side, they still rely on POH generator, which is trusted third party to create time sequences, given that network can only rely on a single POH generator at a time. Wait, what? Which is trusted third party to create time sequences. Given that the network can only rely on single POH generator at the time, it inherently creates a single point of failure, which could jeopardize the security and reliability of the network. But why? Oh shit. Let's just this is good. Exploring vulnerabilities and concerns in Solana smart contracts. Hainan University, Hainan Haikou, China. The Solana blockchain was created by Anatoly Yakovenko. Yo, who are you? Wow. Can we go on Wikipedia? There is no wiki for this guy. There's totally Yakovenko. And there is no languages. Oh. He worked at Qualcomm. Wow. In the early 1990s, Yakovenko moved to US from Ukraine, learned to program. He graduated Illinois with a BS. Bachelor's, right? Uh-huh. Man, this is stupid. I hate it. Oh, no. It's not the browser again. Register before tonight to save. Wait. Yakovenko worked more than a decade at Qualcomm as an engineer working on wireless and distributed systems since 2016. He has worked as an engineer Mesosphere, a company that develops software for data centers, and at Dropbox. Oh, shit. Українець Анатолій Яковенко створює найшвидший у світі блокчейн, як инвесторы заработали на его стартапе Solana под $1 миллиард. Ага, хорошо. Кто такой Яковенко? Яковенко, 41, родился в Украине. Знаете, давайте на английском. There's another reason. He realized that traditional finance was too bureaucratic and would more efficiently. He also liked the idea that thanks to blockchain, anyone could do cryptography. He worked as an engineer at Mesosphere, a company that develops software and data centers. The idea for Solana came to Yakovenko while sitting at a coffee shop drinking 2 cups of coffee and a beer. What? Solana now has 5 co-founders, former Qualcomm engineer Greg Fitzgerald and Stephen Ackridge, and former MedTech executive Eric William and Ray Gokal. The company is named after San Diego Beach, where former Qualcomm colleagues used to serve. Solana is headquarters in San Francisco. The current company employs 78 people. Damn. Okay, blockchain is decentralized network that supports everything and that. Oh. Okay, in 2021, attack targets Solid, Mango, Tulip Protocol, UXD, Optify, Nirvana, Crema Finance, Jet Protocol, Casio, Wormhole. Bruh. Hacker bypassed unverified account. What? Flash loan. Mango attack. What's in Mango attack? This is so interesting. What the hell? Based on recent events, Mango attack refers to a data breaching target, retailer Mango, where the third-party marketing vendor was compromised. The incident exposed customers' contact. What? Okay, Mango targeted in recent cyber attacks, unauthorized access to client information. New hacker attack on fashion company. Mango has alerted. Nah, not this one. Cryptocurrency. Crypto attack swipes 100 million from DeFi service Mango. That's it. Wow. And it's all redacted. No way. I can't watch Bloomberg, man. Let's see. The paper analyzes the activity of blockchain platforms by comparing indicators such as the number of project issues and stars of different smart contract projects on GitHub. This means that this method can reflect the performance of different blockchain platforms in community building, developer support, and ecosystem construction. Generally speaking, the more issues and stars platform has, the more active its ecosystem is and the better the developer support. Therefore, the data-driven statistics analysis method can provide valuable information to the people better understanding and evaluate the environments of smart contract security analysis tool platforms and different blockchain and platform tabs. In actual practice, using code volume to measure the size of projects no longer very accurate because of the project often containing a large amount of third-party libraries, code, and references, or to make the project structure cleaner, the code stripes out of the project. As shown in Figure 1, our collected data shows that there are currently 113 security analysis tools supporting analysis of Ethereum's contracts, indicating Ethereum's dominant position in the field of smart contracts. Ethereum can become mainstream platform for blockchain smart contract security analysis and developers. Data analysis, principles and vulnerabilities. Smart contract vulnerabilities often arise for a variety of reasons, including bad practices, coding errors, and more. These vulnerabilities can lead to smart contracts executing unintended behaviors such as transferring funds to unauthorized attacks, relying attacks, etc., etc. Lack of check. The underlying principles of Solana are different from those of Solidity. It uses a different language, Rust, as opposed to Solidity and Ethereum, and decouples code and data. It defines all addresses as accounts, and each account will store either funds or programs. Programs allow anyone to call them by simply providing input parameters, but this can also lead to serious consequences such as theft of funds if proper identity checks are forgotten. Lack of signer check. The function describing and listing 1 is designed to update the administrator of contract. Its primary purpose is to maintain the security and integrity of contract by allowing only current administrator to initiate changes to the administrator account. To achieve this, the function includes a comparison mechanism that checks whether the incoming account matches the current administrator account. However, this approach has significant flaws. It lacks verification of whether the current administrator actually signed the operation. The omission creates a critical vulnerability. An attack could exploit the weakness by passing the current administrator account as the parameter where calling the function while simultaneously setting their environment own account as the new administrator. Okay, update this program result, let account iter, mutation, account iter, config, we got new administrator. Next, account information, account iter, validate the config account. If admin public key is not config admin, return error, program error, invalid admin account. Lack of ownership check. Wait. Is it still present though? I don't think so. Calculations error. Arithmetic overflow, underflow. Rust is a systematic program engine that provides memory safe concurrency and high performance. Okay, we all know that. The root cause of the vulnerability lies in the multiplication operation, which could lead to an overflow. In Solidity, the maximum value for the unit 256 type is 2 to the power of 256, assuming that the CNT has maximum value, environment, etc., etc. Value is non-constrained. Therefore, an attacker can set the value to a very large number. For example, when the number of receivers is 2, amount will be calculated as which exceeds the unit representation. Okay. Due to the overflow, amount will become at 0. At this point, the balance check required will always pass 0 because less than any balance. As a result, the balance check condition will not prevent a subsequent transfer, allowing the attacker to proceed with the transfer. The critical impact of the vulnerability is that the attacker can bypass the balance check, successfully transferring assets to the receiver's account without actually deducting the amount from the sender's account, which this allows the attacker to make illegal token transfers without having sufficient balance. So it's an overflow, like classic overflow error. Numerical precision errors. Unsafe code. Okay. A sandwich attack means that when a user buys X tokens, the attractor from runs and buys X tokens first, causing the price to slide from P2 to P3 to P2. When the user successfully buys X tokens, the price slides again from P2 to P1. After the price reaches P1, the tracker sells the tokens bought at P3 again. Wait, what? No. After the prices reach P1, the attacker sells at P1. No. This is so bad. Thus, the attacker buys X tokens at the X coordinate, the P3 sells at X tokens, the X coordinate P1, obtaining the price spread. Cool. Oracle acts as an interfaces that connect the apps with the external real app world. Yo, this is gonna be crazy. Various external data resources such as market prices to provide the required data for the apps. However, since Oracle are not under the control of the apps, there is a risk of being manipulated by hackers. Specifically, attackers may tamper with the returned results by manipulating external data sources or attacking the oracle, causing parameters such as prices and dApps to deviate from the real world. If attackers can successfully exploit these vulnerabilities for arbitrage, they may obtain huge profits. Therefore, Oracle attacks have become a major security hazard in the DeFi field. Flash loans attacks are from the Oracle attack. They take advantage of the vulnerability that Oracle returns an incorrect result by borrowing assets in a very short time and quickly returning them to the obtained arbitrage profits. Attackers rotate between borrowing and returning and conduct arbitrage of the difference between the value of the borrowed assets and the repayment amount. Man, this is just crazy smart. The main defense methods include the M of N reporter mechanism, limiting the price change rate, time weighted average price, increasing the minimum transaction delay, etc. By obtaining the prices here and there, Chainlink, Coinbase, etc., and using the median of those data calculated financial results, the risk that any single Oracle provider error, that's it, limiting the price change range by limiting the price functionality. The time weight average price protocol can efficiently mitigate the risk of flash loans. Increasing the minimum transaction delay. Oracle attack arbitrage is time-sensitive operation, as an arbitrary typically monitors the market operating to minimize the risk, etc., etc. Okay, protocol developers. Okay, this is not relevant. Off-chain factors. Key leakage. Okay, hacking of promotion software. Smart contract developers need to communicate and promote their projects to users and promote projects and interact with users through various social media platforms like Discord, Twitter. However, if these social media platforms are hacked or affected by other security issues, it may lead to hackers publishing incorrect information. Static analysis. Static analysis, one of the earlier, that's it. Dynamic analysis. Dynamic taint tagging technology still has many deficiencies. First, it cannot handle the defects that only modify data. Second, it cannot achieve coverage of most paths and can only analyze one path at a time, as shown in figure this and that. Start the system under test. System under test up and triggering expectations, feedback and result, inject. Okay, 1 second. Let's continue. Symbol execution, combined technologies, discussion and conclusion. Let's see the conclusion. As security, whoopsie doopsie, sorry. As security issues related to smart contracts increasingly affect people's confidence in blockchain, the security analysis tools for smart contracts are also bound to receive more attention. As an essential part of blockchain security, these tools are held to higher standards in terms of accuracy, efficiency, ease of use, and many more. This chapter summarizes the main work and findings this paper regarding the security analysis of Solana blockchain smart contracts and provides prospects for future work. Well, this is a good paper. Not because it mentioned anything specific, but because of the whole thing, like the broad view of it. What is an EVM development versus Solana development? Okay, then you can build Ethereum, Polygon, and etc. For Solana, you can only build applications for Solana. ETH. Programming on ETH is much easier, which means there are more competition. Okay. So we have this consensus model, performance metrics, transactions proceeding speed. Solana often operates in low thousands TPS with a theoretical design target of 65,000 TPS on its main network, with burst capacity reaching much higher levels during optimal conditions. This high TPS is thanks to the parallel processing capacity where validators run smart contracts in parallel and efficiency gains from the POH algorithm. Transaction costs. Another notable disparity between Solana and ETH is the different transaction fees, which are required to process transactions and execute smart contracts. Historically, Ethereum's slower transaction speeds led to a higher network congestions and increased transactions. Solana, on the contrary, consistently maintains a low transaction cost, often mere fraction of a cent, lower fees, TPS, etc., etc. As these networks continue to evolve, addressing transaction costs remains a primary concern, while Solana works to preserve its low-cost advantage. Ethereum is actively developing scaling solutions to lower fees and increase speed. Network stability. Another distinguishing characteristic of these platforms is the reliability and stability. For instance, ETH has constantly demonstrated exceptional reliability since its inception, typically experiencing few network outages in history. This sustained stability reflects its conservative approach to protocol changes and its security-centric design philosophy, which favors network's resilience. Conversely, Solana has encountered several notable outages. Wow, and it's gone. What? This is pretty cool. Let's just search Solana. Why can't I open Solana? Let's see incident. Come on. Come on. This is wrong. So we have some outages, but it's really hard to explore the thing. Integer overflow. This issue stemmed from a bug which stakes this and that. Wait, I have to check my messages real quick. I have to do something real quick. 1 minute. Okay, um, I think I have to find something more interesting to do. Centralized concerns. Use case consideration. Solana uses case overlap with ETH to some extent, such as DApp, development, DeFi, NTFs, and NFTs, and DAOs. However, each platform is practically well suited for different applications. Some of the top ETH use cases include complex smart contracts, Ethereum's mature development tools, and extensive auditing experience bolsters the development of applications that require sophisticated contract logic or advanced cryptographic techniques. Institutional applications. High-value DeFi protocols, high-frequency applications, real-time applications, microtransactions and tokenization. Consumer-scale applications. This is interesting. Okay. Cool. Solana's token economy. Solana is particularly inflationary and not fully deflationary. In other words, it incorporates deflationary mechanisms that balance its inflationary nature. To explain, Solana maintains a predictable inflation schedule. Initially set at 8% annual inflation rate, this rate decreases by 15% annually, called the disinflation rate, until it reaches its fixed inflation rate of 1.5. This schedule provides predictable rewards for validators and stakers while avoiding excessive token dilution. All inflationary issuances are allocated and token holders based on their staked Solana, in addition to the validators who receive commissions from the rewards generated by the delegated Solana. However, the actual inflation is influenced by factors such as token burning, low-cost private keys, and slashing events. The token burning mechanism burns a portion of each transaction fee, thereby counteracting inflation and forcibly scarcity. The validator process for processing the transaction keeps the remaining fees. Solana's staking yields typically range from 4 to 8% annually, higher than Ethereum's rewards but offset by ongoing token inflation. The platform allows liquid staking through various protocols, enabling stakers to maintain liquidity while earning rewards. The economic model reflects Solana's focus on user adoption over speculative value creation. The low fees encourage usage and application development, while predictable inflation provides sustainable validator incentives. Interoperability and cross-chain solutions. Interoperability has become fundamental principle in blockchain development, with users doing what? The schedule provides this and that, all inflationary. Okay, Ethereum serves as the hub for most cross-chain activity, with several bridging solutions and layer 2 protocols. For instance, Polygon elevates congestion on Ethereum maintained by processing transactions off-chain. However, Ethereum still serves as the primary settlement layer, extending its security, liquidity, and user base to other chains. Major bridges. Solana connects to other networks primarily through bridges. Bridge like Wormhole, for instance, facilitate assets transfer between Solana and multiple other blockchains, including Ethereum and BNB Smart Chain. The platform's fast finality makes it attractive for cross-chain applications requiring quick settlement. What's more, its integration of cross-chain messaging protocol (CCMP) further enhances its interoperability with other blockchains. However, cross-chain bridges are not without their challenges. Their existence doesn't necessarily guarantee the security that on-chain activities enjoy. For example, bridges like the Ronin network and Wormhole Bridge have lost millions of dollars due to smart contract flaws or private key compromises. Wow. Institutional adoption and use cases. Ethereum's enterprise presence. Ethereum currently leads the blockchain industry with a robust ecosystem and wider market adoptions. As a pioneer of DeFi sectors, Ethereum hosts over 5,000 dApps, including Feavel, Uniswap, and MarketDAO. Its market dominance extends to the NFT sector, as well with popular collections such as CryptoPunks, Bored Ape Yacht Club, and etc. etc. Besides the substantial market share, major corporations and financial institutions are increasingly adopting Ethereum for various use cases. The platform hosts numerous enterprise applications from supply chain tracking and digital identity solution. JP Morgan JPM Coin, despite operating on a permissioned Ethereum fork, demonstrates institutional confidence in Ethereum's architecture. Wow, that's interesting. Moreover, its established compliance framework and regulatory clarity in many jurisdictions make it attractive for institutional adoptions. Its predictable upgrade schedule and conservative development approach provide the stability enterprises require for long-term planning. Additionally, the U.S. sanctioning spot Ethereum exchange traded funds, basically ETFs, in July 2024, spurred increased institutional adoption and an influx of capital from the traditional finance market. Solana's growing institutional interest. Although novel to the institutional arena, Solana has rapidly attracted organizations seeking blockchain solutions offering high throughput and low-cost transactions. Trading firms and financial institutions exploring high-frequency dApps, for instance, often evaluate Solana's for performance characteristics. Solana's growing ecosystem of institutional-grade infrastructure providers, including custody solutions and compliance tools, supports broader adoption by enterprises. These services address institutional requirements for security, compliance, and operational excellence. With that said, several TradFi players have launched products on Solana, attracted by the speed and cost advantages. Gaming and NFT ecosystem. Ethereum's Digital Asset Foundation, EDAF. Wow. Ethereum forestanded a continuous dominance in the NFT market, with platforms like OpenSea Foundation and Super Rare facilitating billions in trading volume. The platform established standards making it suitable for high-value digital art and collectibles. In fashion, gaming projects on Ethereum focus on asset ownership and interoperability, with games like Axie Infinity, the sandbox creating extensive economies around NFT-based items and characters. Its security makes it sustainable for high-value gaming assets that players expect to retain long-term value. Solana's gaming innovation. Solana's speed and low costs make it ideal for gaming applications requiring frequent interactions and microtransactions. It enables games to implement complex mechanisms such as real-time on-chain battles and frequent reward distributions without prohibitive transactions costs. Projects like Steppen and Star Atlas demonstrate Solana's capability to support massive multiplayer experiences with blockchain integrations. Put another way, the platform enables gaming mechanisms impossible on higher cost networks. Environmental considerations and sustainability. Solana's energy efficiency. Okay. Technical innovation and future development. Ethereum's development roadmap focuses on completing its transactions to a fully scalable, sustainable platform that solves the blockchain trilemma. Key completed or ongoing improvements such as proto-dank sharding, a step toward full sharding. We're going to read that. Account abstraction work and continued L2 expansions. The platform's research-driven approach emphasizes long-term sustainability over rapid feature development, such as Ethereum researchers publishing extensive documentation on purposed improvements, subjecting changes to peer review and community discussion. Fusaka upgrade, one of the upcoming upgrades, aims to... L2 data capacity and making running nodes more accessible. This improvement will also enable forks to adapt faster A2 scaling needs. Further upgrades such as single slot finality are expected to reduce block finalization times, substantially improving network efficiency and user experience. Solana's innovation pipeline. Solana versus Ethereum comparison. Wow. Okay. So basically Solana doesn't have that much verifiers. Staking requirements. Total value locked. Smart contract standards. Network stability. Upgrade mechanism, Ethereum improvements, Solana improvements, etc. This is a great article, I should say. Great one. Okay, sharding. In the context of blockchain, sharding refers to dividing the network into smaller partitions to improve accessibility. That's it. Ethereum Fusaka upgrade. The Ethereum Fusaka upgrade is a network improvement that aims to dramatically increase layer 2 data capacity. And reduce transaction costs. Nothing interesting here. This is very interesting. So you can launch your own token. What's this? Crazy though. Build on Solana with fastest RPC nodes, a comparative library for Web3 APIs, and the most performant blockchain Ethereum tools. Hmm. Clusters and public RPC endpoints. Okay. I want to explore what wallet is good to use, because I don't have a Web3 wallet yet. What are the best Web3 wallets? So we have um, we have Phantom, Backpack, Coinbase, Lit, and others. Hmm. Welcome to OKX Wallet. I just saw treasure somewhere here. Yep. What's Trezor though? So they sell these products, pretty cool. Let's see Ledger, what's that? Okay, so they have these extensions and then you connect them with keys. Okay, let me set up a wallet real quick. Okay, so I have connected an Phantom wallet and it looks something like this. So Okay. So they have this trading application. Let me quickly log in. Okay, so let's see it in a full view. This is very interesting. What's this? What is XYZ 100? Oh, wait. Pretty cool app. I think you can also draw lines here like this. Pretty fun. This is pretty fun. But yeah. So, okay, we have these platforms, but how do we integrate this into our own app? On a high level, let's bring it back to the screen. On a high level, mainnet, live production environment for deployed applications. Debian testing with public accessibility for developer experience with the applications. Stress testing for network upgrades and validator performances. Okay. To connect to the DevNet cluster using the Solana CLI. Testnet is where the Solana core contributors stress test recent releases features on a live cluster, particularly focused on network performance, stability, and validator behavior. Are not real. Testnet may be subject to ledger resets and airdrops for application testing. Entry for testnet. Okay. Permissionless persistent cluster for Solana users, builder, and validator, and token holders. Tokens that are issued on mainnet are real Solana. Gossip entry point for mainnet. Example Solana command line configuration. To connect to the mainnet cluster using Solana CLI. Okay. Enter the following command line into the terminal to install the necessary dependencies. Successful installation will return up like this. I think we should do it, for the purpose of like fun, because why not? So the first thing that we will do is copy the command. But we are going to open some other folder. Okay, so we have this empty folder and project. It's a really quick update. Let's try again. We're getting LLVM. Yeah. So this might take up some time. Yeah, boy. Great. First time installing Solana. Let's explore Solana CLI basics. Solana configuration, Solana config get. I think I have not installed the dependencies properly. Let's do it right now. Nice. So we have the Solana CLI right now. Okay, so we have Node version manager. We have NVM, Node, and NPM. Okay. Oh, wait. I have Node. Yo, I have Anchor CLI. Okay. Do I have this? Yep, I do. Okay, cool. Solana CLI basics. Let me just, okay, config, confirmed everything. So here we can generate a new wallet. You know what? Maybe we should explore the Solana CLI next time, because I already hit 2-hour mark. And this was a great experience in exploring Solana. We should do more of this. Okay, so anyway, see you in the